All right. Okay. Yeah, like I mentioned, I just lowered the stream bitrate a little bit, so let me know if there's less buffering, and also let me know if the quality is worse or if anything is unreadable. All right. So we have our population slowly dwindling away to almost negative 2,000. Arkham is asking what's my buffer size, and I'm not quite sure how to answer that. OBS is saying on my side that there have been 0 dropped frames, so I don't think there's a problem on my end as far as I know. But if anyone has links to articles or tips on how to improve the stream quality, be sure to let me know. Interesting. Everyone says it's worse. Well, one other thing, for those of you having trouble, if you can also send me a link to, if you watch any other streams that you are able to watch fine, send me the links to those too, and I can try to do some research. All right. Well, let's continue then. So we have our population. And what's next? I guess, well, we've got two things. Why don't we try doing, spending a little bit of time rendering some graphics here. And then we can take a look at the simulation once we get some graphics up. So, I was doing a little research yesterday about the best way to do this. So there's a couple there's a couple ways to there's a couple ways to do graphics. So at the moment, most real uses, people are gonna write their own SVG. And there's a couple there's a couple packages on here that can be used. So the Elm graphics one is the old graphics package, and it's not really maintained anymore. There's a new thing called Elm Playground, which hasn't been published yet, but is intended for making it easy to do quick graphics rendering. And then I also saw this package from Quartz /render, which seems to have a pretty nice API, and but is still kind of experimental. But it uses SVG under the hood. So I wanted to try that out, although I think for the planet we might want to try using a graph for the moment, and then we can try using the other graphic stuff when we actually have a full system. So let's see, there was actually a package that was for doing bar charts and pie graphs, and these two seem to be based off of each other. So this one has a higher version number. I assume it's been updated more recently. So I want to try just integrating this real quick. So I guess this will be a little detour from the planet sim for the moment, but see if we can use this to render our planet. So let's try that out. Grab this package name. We will Elm package install this. And take a look at the documentation. Here's the pie chart. We give it a list of floats and a list of strings. And we should get, we get a model out of it. And what do we use for models? Okay, then we can put a title on it if we want. We can optionally give it custom colors. We can add value to label. I don't know what that does. And then we can render it with 2HTML. Okay, so let's give this thing a try. So in our planet sim, rather than just printing this out, let's create a chart. So we're going to make a chart.py, and we're going to give it a list of floats. All right, so that'll be model.planet dot, what did we have in here? Resources, food, population, and technology. So we've got resources, model.planet dot food, model.planet dot population, and technology. So most of these are ints, so I think we're going to have to convert these to floats, but I'll wait for the compiler to double check on that. Then we give it a list of strings. Food, population, and technology. And then we get back a model. And then we want to take that model. We get a chart model. And we want to take that model and let's put a title on it. Chart.title. And let's actually give our planet a name. I'm going to jump to planet for a second and add a name attribute, which will be a string. And our test planet will be Testopia. Yeah, Max is noting that this API would be better having a single list of tuples, which I agree with, because the problem here is you may not have the same number of items in each list, and I don't know what'll happen if we do that. Maybe it'll crash, or maybe it'll just make up random names. Who knows? But yeah, this would be a bit better of an API if it took a list of tuples, which would be the string and the value. So who is this? Simon H1000, if you're watching, maybe consider that for your next version of this package. All right, so we've attached the title, and now we still have a chart.model, and we want to convert that to HTML. So we'll use chart to HTML. All right, oh, I think I didn't import chart. So let's try it out. Dun, dun, dun. My type annotation does not match. Oh yeah, so the same thing. These are all ints, but it wants floats for all those. So let's go ahead and to float these. And the last one is a float already, although I was planning for this to just be between 0 and 1. So maybe we should like multiply this by 1,000 or something. And maybe I'll put a note on here also. All right. Here we go. And we've got Testopia with lots of resources. Oh, that's cool, actually. Kind of like a responsive layout. It puts the key on the right, and if I zoom in, it puts the key on the bottom. And we've got food, we've got population, and I thought there was like a blue sliver in there. Huh, yeah, there's a color in there that looks like it's not in the key. So, there might be bugs in this library, but I do see the population decreasing. So that's good. So let's go ahead and write our better algorithm. I'm going to scroll back and check the chat for what least fixed point was suggesting. And yeah, feel free to make suggestions as I'm writing this part of what algorithm we should use. So least fixed point was suggesting that population should increase based on food. Food, I guess, should increase. So that's something that in Simon's simulation, one of the important things was like a negative part of the feedback loop, and in his simulation, he was using pollution. So let's add pollution, which will also be a float between 0 and 1. So, all right, so we'll have resources. Resources will decrease based on, let's say, the population and the technology as well. Because if you have better technology, you can consume the resources faster. So resources will be planet.resources minus planet.population times some amount, which I think, let's say it's 0.1 plus the technology level. And let's see, I think I mismatched parentheses maybe. Got that one, that looks good. What did I mess up here? Oops. Population equals. Oh, I didn't put a comma here. There we go. Oh, thanks. Thanks, Greg. Yeah, and Greg mentioned on Twitter that he's going to be starting a video series or streaming. I wasn't quite sure about making an RPG maker in Elm, so that sounds really cool. So I will be sure to retweet that on Twitter when he starts that. Okay. So resources are going to decrease based on the population and based on the technology level. Then we're going to have food decrease based on the population. It'll equal planet.food minus the population, and it's also going to regrow. So let's say why don't we actually add a constant here? we'll have planet.foodgrowth. And that will decrease based on the pollution level. So we'll multiply that by 1 minus the pollution. So we have the food, we'll subtract food for the population, we will add food growth, but that will decrease based on the pollution. All right, so in that case, we're going to need a food growth attribute, which will be an int. Probably actually most of these will need to be floats in a second because we're going to have fractional values. Then what's next? The food growth will always stay the same. The population is going to, why don't we say it'll multiply by 1.01. And this is not quite right because we'll need to subtract something. But we will look at that in a second. Then the technology level will equal the planet.technology level. And let's increase it based on the population. So over time, it'll just naturally increase. So we'll multiply by population over 100,000, and then 1 plus that. So this will mean we'll get some, so if we have like 1 person, then it'll increase by 1 in 10,000th. All right. And then we need the pollution level also. The pollution will equal, and I guess this can just be set. This should probably change over time, but let's just try something simple. Population. And I guess it should be the technology level. Why don't we just set it to the technology level for the moment? All right. So population is not defined. It's in the planet record. Then food growth, we need to define. Let's set that to 500 to start with too. And now it's complaining these aren't all floats. So actually, why don't we just make these floats? I don't really see a reason for them to stay integers. And in the annotation for view, okay, so now back in our view function, I don't need the 2 floats on these anymore. All right, so here's our new simulation. Food is increasing by a lot. I'm actually going to go to the view and stick this in a div and also put the toString of our model here, as well as the chart. This is l.div. And need a html.text here. All right. So we've got lots and lots of food growth, and the population is increasing. And the technology is not increasing. So I was expecting that to go up. Let's look at the technology. So I was expecting to take the population, which right now is like 300, divide by 100,000, and add 1 to that, and multiply, because it starts at 0. All right. So why don't we just put an if statement here? If technology equals 0, then we will just have it start out equal to this. All right, let's try that again. All right, so now we have some technology level. The food is continuing to increase. So this planet's just getting overrun with animals and plants. And the technology is slowly increasing. But we do have some sort of simulation. It is a pretty random simulation and is not really backed by any solid foundation. But we do have the basics, and this is easily customizable as well. Oh, what happened here? Oh, the resources went negative. Ah, okay, so we should probably prevent any of these from going negative. So I'll just use a pipe operator here. The resources should never be less than 0. So that should be, take the max of that and 0. And the same for food, max 0. And the same for population. And also, same for, well, technology. I don't think these can produce a negative value. And neither can pollution. All right. So here's our planet. Hopefully this is interesting to everyone. I'm like kind of geeking out about simulations in general, even though it's just numbers in a pie chart. So I guess we should move on to making multiple planets and putting them in our star system, and we can get some better graphics with that. Well, this planet simulation is probably not that interesting, but yeah, again, these equations we're using in the step function can totally be customized as well. Yeah, okay, so we just hit 0 resources, and now what's happening? All the food is going away. Okay, so we ran out of resources and then all the food went away, and now the population's still growing. So that's one problem. But maybe this is a realistic thing. Maybe they've found ways to not need food anymore. Who knows? Okay, so I'm gonna commit this, and oh yeah, here. Oh, I know. The one other thing we should try to keep track of is the age of the planet, because that'll be interesting to have, so we can see how many years have elapsed. And actually, I'm also gonna maybe speed up this simulation so it'll run faster. So we'll have the age as an int. In our case, let's start, since we're starting with civilized population, let's start the age at, well, it should probably be a lot. I guess we can just have a relative value. So this will be year 0, or iteration 0, and we'll just increment that every time. And in our view, let's put that in the title. So we'll have a space, parens, and then we'll have toString model.planet.age. Let's see, I messed up something in the compiler. Oh, no, I didn't. Okay. Cool. And I'm going to speed up the simulation a little bit by going to the single planet. Going to the single planet sim. And in our subscriptions, let's make this every 50 milliseconds. See how that does for my CPU. Okay, that still looks fine on the CPU. And we're going a lot faster here. There's the population starting to explode. Okay, so in about 300 years. So our constants are probably really weird, but I'm going to commit this, and then we can move on. So we added the chart. We added our update. Yes, then the technology ate the population. Well, all right. It looks like we still have, I can't even count, like still 20 million 20 million units of people on here. And the technology is infinite now. So yeah, we can definitely use some tweaking on our algorithm, but let's move on and start building our solar system. Because we have this nicely divided, so we can come back and adjust the way the planets work at any time in the future. And yeah, great. Glad to hear there's a bit less buffering on the stream. All right. So what's next? We want to have a star system. And I think we'll want to kind of follow the same pattern. We're going to define a star system data structure and the logic in one module, and then we'll have a separate module to run a star system simulation. All right, so let's make our star system.elm. Exposing. And this will have, what did we expose in our planet? Oh, we just exposed everything. We don't want that. We want to expose the planet, the test planet, and step function. So let's expose our star system type. I'm not sure we need to expose a test thing. We should actually probably do that in the sim module. And then we'll also have a step here. So let's start by defining our type. So I guess we're going to have, there's a star, maybe even multiple stars if it's a binary system. But let's say we have a single star. And the main characteristic of a star is its mass. So let's just have the mass for now. And then we should have planets. And that's going to be a list. But what should it be a list of? We're going to have the planets themselves, which will have their technology and everything like that. But we will also need some more information. And specifically, I guess we'll need to know the distance and maybe the orbital speed So let's have a list of records. So we'll have a distance, and actually there's probably a better astronomical term for that, of the distance of a planet to its star. That'll be a float. And the orbit speed, I guess, will also be a float. And then we'll have the planet itself, which will be a planet. Which is maybe kind of confusing, because really this whole record is representing a planet, but this is like the internals of the planet. So we'll need to import that, exposing planet. Then we're going to have our step function, which will take a star system and return a new one. And for now, well, this is actually easy. What we want to do is basically run our planet step function on each of the steps. And then we'll also want to do something about updating their positions. So, and I guess we don't even have a value for storing the position yet. So let's see. So we're going to do a list.map, and we'll have an update planet, and we'll map over all the planets in the system. And let's define update planet. So maybe we should call this internals or something. So our update planet for now is going to get this record. So this is just going to update the internals of the planet to equal planet.step of the previous internals. So yeah, internals is maybe not the best name either, but I did want to distinguish it from the concept of planet, which is kind of meaning different things at different levels now that we're using it. All right. So this is a decent start. It doesn't actually move the planets in the system, but it will do the updates. So let's see if we can make now a planet sim. So why don't we try this? Let's duplicate our single planet sim, and we'll call this one the single system sim. Let's go through and just update what we need to. So this has model. Okay, we'll should need all that stuff. I don't think we'll need the chart. Then our model here is going to be a star system, which we will need to import. And we'll start out. We'll just put our test data in here initially. Then our update function, instead of ticking a planet, is going to tick the system. And then our view, we'll want to actually draw some graphics. But for now, let's just toString the model. And we're still going to update our subscriptions. And let's see. Then we'll go to main. And instead of single planet, we will use our single system. Let's try that out. Let's see. Oh, all right. Looks like Arkham's still having some stream problems. Let's see. OBS did drop a few frames a while back, but looks like my network is still fine on my end. So yeah, if other people are having trouble with the stream, please let me know, but sounds like it might unfortunately just be a few people's computers. Okay, so we have a type mismatch. Wonderful. So this is in starsystem.elm, and the type annotation says it's supposed to have planets and star mass, but it's inferring this. Okay, let's look at where it's talking about. Line 17 is here. Oh, yeah, so I didn't actually correctly update this record. System, and then we're replacing the planets. Okay, that looks better. Now, in single star system sim, we did not define our initial system properly, which is true. So system is going to have a star mass of 1, let's say, since we're not actually doing anything with that. And the planets will be a list, and let's use planet.testPlanet, and I guess let's just make a couple of those. So we'll have 3 of those. And that's not going to be correct either, because I'm giving it the planet.planet data, but we really need a record in here with distance equals 1, let's say, orbit speed equals 1, and internals equals this. So we're kind of exposing a lot of the internal data structures to different models, which is not that great. But also I don't have a clear picture in my head of how the ideal way to structure this is yet, so I'm kind of just going with this at the moment, and we can come up with a good way to refactor it later on. So let's maybe have one as a distance of 5 and an orbital speed of 3. All right, so here's our 3 planets we're going to have. And, well, we've got something here. So it looks like let's see, is there a way I can pause this? Let me just take a screenshot of this. Let's see, pop this up. So here's what we've got in here. We've got planets. Here's the first planet to there. Okay, here's the second planet, also called Testopia. Okay, so it looks like we've got 3 planets. So let's try rendering this out. So let's go to our single star system, and let's take a look at one of these graphics packages. So I haven't actually used any of these recently, but I want to try using this Quartz render one, since it says it's backed by SVG. So let's give this a try. I'm going to download this. Do Elm package install. All right. Looks like for some reason it needs an older version of ElmLive core. Take a look at this. Elm package. Dependencies. Yeah, okay. So this should probably say 5.0. Not sure why, but that version bounds. Let's see. Are events supported? Alright, so let's just file an issue here and see if there's a reason they put that limit on. Should support ElmLang core 4.0.x. Let's see. Currently limits the ElmLang core version to less than or equal to 4.04. I think the version bounds should be changed to be less than 5.0. Alright, so let's just file that. And in the meantime, we will go ahead with using it. So, bring up the docs again. I can get back to the docs. Here we go. So I think we want to make a circle for the star. And then we can also draw the orbits of the different planets. So let's make sure there's a circle in here. Looks like there is. Red circle, we say circle 10 and then give it a fill. Okay, so let's try drawing the star. And we'll start off with just their example. And let's see what we end up with here. Oh, first of all, we didn't switch our main over to use the... Oh no, we did change it to use single system. So why is this not using the new view? Let me try cleaning things again. In the Elm stuff, build artifacts folder. And rebuild this. Yeah, okay, so we got compile errors. So we hit another case where the current Elm compiler is buggy and doesn't notice that it needs to recompile. So you may run into that yourself. You can just delete the Elm stuff build artifacts folder if you're suspicious of that. So let's see. We need to import graphics.render. And it looks like it's probably going to be simplest to just import everything. And RGB comes from color, so I'm just going to use that or qualify that. Import color. And finally, we have something that is not HTML. So what we have right now is one of these graphics forms. So we need to find a function that will produce HTML in here. Rendering. Okay, so we can do it with this SVG thing. SVG, we need to give a size, it looks like. The width, the height and width of the view box in pixels. Huh, okay. Let's say 100, 100. Let's try it out. Great. So there's our little circle. Let's make this maybe 500. And And I'm just going to inspect this and see how big it is. Cool. Great. So that looks good. So there's our star. Then, so why don't we take this and start dividing this code up a little. So we'll have our star. Then let's make a group. Have a star and the planets. And the planets will be looping through each of our items in the model. Model.system.planets. And then let's define what a single planet looks like. And for now, I guess let's just make it a smaller circle. So maybe a 5 circle and make it some kind of green. And let's just use color.yellow for this one too. And this also will give us a list, so we'll need to put a group here. Well, okay. We've got tiny little green planets in the middle of our star. Oh no. So we do need to transform these. So I think there's a move in here. Yeah. Great. And we can also use rotate. So this hopefully will be some pretty nice code. What does move take? An X and a Y, I'm assuming, and then a form. All right, so let's move it by 100. Okay, so that moves it down. Try moving it to the right. Yeah, there we go. So, let's see, what's the best way to do this? What we want to do is take the distance that's in our planet model and I guess multiply that by some constant. E.distance times. Okay, so there's 2 of our planets, and I think our third one is off the screen, so maybe let's shrink this down a little. There we go. So, yeah, there's some planets for us. What I would maybe also like to do is also draw the orbit, or like the path for the orbit. So let's see, can we make, oh, I just saw something called dotted. Name is dotted. Yeah, let's make a dotted line for the orbits for all these also. So let's make a group for each planet. And also put a circle that's not moved that has a radius of this. And this will be dotted color.gray. Same as solid. What is the float for? Oh, that's in solid fill, dotted. Okay, so I guess this is the line thickness. Line thickness, color, line? What does line mean? Oh, this makes a dotted line. It doesn't it doesn't give a dotted stroke to our shape. That's too bad. Let's see, so there's a fill style. Oh, okay, so we can make a line style though, and then apply it. Oh no. have a line style here. Is there a way to apply a line style to a circle? Looks like it's called border. Okay. Texture fill with border. Can have a shape. And solid fill with border. So it looks like there's not really an easy way to make a border without filling. I guess we could fill it with like a transparent color, but I'm just gonna save that for later. And we'll put a to do here. To do, draw planet orbits. All right, so everything's still good. What we need to do is let these planets move around. So that is in the star system. So here we're updating each planet. Update planet, and when we do that, we step the internals of the planet. But also, we want to change the orbit position. So let's define that. And I guess this should just be defined in terms of an angle of how far it is around. So let's make that a float. And the orbit speed, I guess we should just add the orbit speed to this. That seems reasonable. And then we'll use the orbit position to rotate the planet around the center. So here we're going to move it first, and then we're going to rotate. Let's look up the docs for rotate here. Okay, great. Changes the angle. It doesn't give us any more info than that. Let's just rotate it by the orbit position. It's in there. All right, let's see what happens. So our init isn't correct because we need to add orbit position to each of these. This is a case where maybe the fact that the internal details of this record are bleeding over into another module is not that great, because now we've got to update it in all these other places. All right, so nothing seems to be happening. Why don't we also print out for the moment our SVG here. Also stick this in a div and just put the toString of the model and then also show this. So now view doesn't match on line 66. That's this. Argument to div. Oh, I forgot to give the list of attributes to the div. Okay, so orbit position is in fact increasing. Oh, so maybe we're doing these in the wrong order. Not familiar with this graphics library. Let's try putting the rotate first before the move. Nope, that still didn't do anything. Okay. I would think that it should go after. And there's no example here of what units the rotation is in. So maybe it's just in like percentage of turns. Try this. Nope, that's still not moving. Okay, well let's try rotating by 0.5. And let's take off this div, the toString for a second. So what's going on? The rotate doesn't seem to be doing anything. So let's make these squares, see if it's actually rotating. Oh, there's no square in here? Maybe there's a rectangle? Yeah, okay. There's a rectangle, 5, 5. Ah, okay, so the rotate here is rotating the planets. You can see that. But I was trying to figure out how to make it rotate the shape around the center. I'm kind of surprised that swapping the order of these doesn't make that happen. Yeah, it's still just rotating the shape. So how do we make the rotate take the move into account? Do we have to like put this in a group? And then rotate it? Position, angle. That's the angle of a form. Rotate modifies the angle of a form. Interesting. So maybe this library just doesn't handle composing transformations properly. Let's try taking this and putting it in a group and then rotating the group. Hey, there we go. Okay, so that's better. Now we can make these. Actually, why don't we just leave these as squares for the moment? And we've got some little planets now. All right. So I am going to commit this then. And then let's take a little break and come back and figure out what we want to do next. Yeah, I think there's a lot of options open for what we do next. So if there's something in particular that you think we should do, why don't you give suggestions in the chat while we take a short break. So let's see. Created our new single system module. We pulled in this rendering library. And we created our star system. And actually, all these star systems also are running their own populations, and all that stuff is going on. We just can't really see it in this particular rendering of the system. All right, so I am pushing that up. And let's take a short break. I will be back in a few minutes.